You are watching Bloomberg Tech Europe. Coming up, today we step into the world of quantum computing. Machines many believe will redefine how high-performance processing and the speed at which we crunch data. Backers say the technology could transform entire industries, from drug discovery and cybersecurity to global finance and national defence. A leading quantum entrepreneur tells us Europe could actually win in the frontier tech if the ambition is backed.
You only create this position of strength if you actually have something that you control. And I think in this way, controlling the quantum supply chain, Europe is very strong. As said, we have many companies in Europe, and now we just need to scale it.
So, can quantum deliver on its extraordinary promise? In this episode, we spotlight the progress that's been made and the path ahead with insights from key industry leaders. Welcome to Bloomberg Tech Europe. Quantum computing. Some see it as the next frontier in high-performance computing. It's built on a fundamentally different architecture that can, at least in theory, crunch data far faster than today's most powerful machines, with massive potential implications. So we ask, can the tech live up to the hype? And can it supercharge the AI boom?
This processor, built by Alphabet, took 5 minutes to solve a problem that one of the world's fastest existing supercomputers would take 10 septillion years to answer. That's right, longer than the age of the universe.
The experimental Google machine used what's known as quantum computing, technology at the heart of the next great race from Washington to Beijing for commercial and military supremacy. It could mean accelerated progress in areas like drug research, artificial intelligence, defence and finance. Today's computers use binary units called bits and perform their tasks sequentially. Quantum computers use transistors called quantum bits or qubits. They handle data in parallel and can consider many different possible outcomes simultaneously, narrowing them down until the correct answer is worked out in a fraction of the time. Google, IBM and others predict there could be a quantum computer solving real-world problems by the end of the decade. That's the hope. The challenges include providing massive power supplies, ultra-cold temperatures, and slashing error rates.
But with each breakthrough, the time frame narrows. Late last year, Google said an algorithm running on its Willow quantum computing chip could be repeated on similar quantum platforms. Another major leap.
And just like the AI race, the battle to dominate quantum computing is shaping up as a fight between the US and China. But Jan Goetz, the co-founder and CEO of IQM Quantum Computers, says it is vital that Europe plays a leading role. His company, headquartered in Finland, specialises in building superconducting full-stack quantum computers. IQM has raised $600 million to date and is working with the likes of Nvidia to integrate quantum into existing computing hardware. Goetz says Europe must compete or risk weakening its global standing and losing its seat at the table.
If you look just at the number of startups in quantum, for example, there are more in Europe than we have in the US, for example. So this is really not the issue. We have the fundamental science, we have the research, we have the early stage venture. What is missing is two things. It's those companies that scale to become global leaders, and it is the industry engagement. There are no tech companies in Europe that invest heavily like you have big names in the US, the likes of Google, IBM, Amazon. So I think these are the two components that are missing in Europe, and this is the gap we have to fill, and this is what, of course, we try quite actively as IQM, really growing into this role, stepping up, taking a global leadership position, and then activating ecosystems that include corporates to support this journey.
Are you seeing that urgency from Brussels and other governments in Europe to support this technology?
Yes, so I think on the political level, the understanding is there, the will is there to support. I think many countries and also the European Commission have been announcing quite strong quantum strategies on what they want to do. Where we are often missing out in Europe then is the execution part.
Is quantum computing critical for European sovereignty?
Yes. quantum computing on the use case side, it has a lot of, let's say, very beneficial use cases for humanity. If you think about drug discovery, better materials, or fertilizers. But then it also has a dual use aspect, in particular on the code breaking part. So with a large enough quantum computer, you can break our current encryption scheme. But of course, as every technology, also you find other dual use applications in quantum computing. And I think it's very much a sovereign technology where Europe needs to make sure that we have a grip on it and we don't fall into dependencies that maybe we see at the moment in AI.
On that point, you can make the argument. There are those who make the argument that Europe has already lost when it comes to the AI race, particularly when it comes to the hardware, when it comes to the chips, when it comes to the large language models. If we lose this race, what are the consequences?
Well, I think AI also is still a, let's say, relatively young technology. And I think where Europe is strong at still is the industrial part and the adoption. And this is both true for AI and quantum. And if industries find out that there's different ways to use AI, maybe smaller models, more streamlined models, I think this could be a way to go. And similar actually is true for quantum. We just need to find our way. There are actually more quantum computers deployed in European data centers than in US data centers. We have sold more quantum computers into data centers than any other company out there. So there is a way to lead also from Europe. We just have to find it. So in the US, people have been betting a lot on the cloud business model, which is fine. And we are also driving the cloud adoption. But on the other side, there is also a way then to lead on the infrastructure part and going into data centers. So I think we should not always try to just copy the US and try to make it better or faster. We have to find the European way and then make sure that the European way is better.
Well, can we commercialize as quickly as the US? Is that another avenue in which the US could take a lead, is commercializing this research?
I think so. I think there's a good example. For example, in Denmark, you have Novo Nordisk, one of the big pharma companies. They have been investing larger amounts into quantum, which shows that actually industry is chipping in. On the infrastructure side, in our last funding round that you mentioned, we had the Schwarz Group, so an IT data center provider from Germany, investing into us. So I think the industry is getting there, and this is now what we need to do as a quantum community, is to activate the decision makers in these European companies to really adopt the technology. But then ultimately it's a global business. I mean, we are selling also in the US and we are selling in Asia. So I think also we should not be so narrow-minded and think we need to build like the supply chain and everything only just from Europe, because then we are missing out again big part. I think the mindset that we need for Europe and in European companies is that this is where we come from, but we go global and we go big. And this kind of ambition level and going big, this is what's often missing, I think, in European startups.
I know you get asked this all the time, but in terms of timelines around commercializing your quantum computing solutions, what are you currently targeting?
So from a product perspective, actually we are selling actively quantum computers, and we are selling on the one hand side into the educational market, which is actually very important and very strategic, because there is a shortage of talent already today. And our goal is that each university around the planet has one of our quantum computers to train their students, so that later on when they're in their jobs, they remember from which technology they learned on. So this is one thing, and the educational market is there and growing. Then we sell into the supercomputing market, which is also a growing market, and these are the big computing centers, and what they do is they integrate the hardware into the computers that they already have. So quantum computing is not a standalone technology. It will work hand in hand with GPUs and CPUs. For example, we are working actively with Nvidia and other partners to integrate on the hardware level. So this is the level of commercialization today, and of course the next step, and this is really where the big potential comes, is then unlocking the applications. And the first ones will probably still be a few years away, and then is, I think, when the industry will really pick up.
What are the consequences if Europe does not play a leading role in quantum computing?
Well, I think we will fall into dependencies again, and this just weakens our standing, not only on the business side when it comes to access to the technology. I think also ultimately on a political level, Europe will lose its seat around the table when the big questions are being discussed. So I think it's very important that Europe can argue from a position of strength, and you only create this position of strength if you actually have something that you control. And I think in this way, controlling the quantum supply chain, Europe is very strong. As said, we have many companies in Europe, and now we just need to scale it.
Well, that was Jan Goetz, CEO and co-founder of IQM Quantum Computers. IonQ, meanwhile, is a US-listed quantum computing hardware and software company, one of several players hoping to take the tech mainstream. We spoke to the CEO of that company about how Europe stacks up against the US and the progress being made in China.
Well, I fancy IonQ's chances, most and first of all. I think that beyond IonQ, there's a very vibrant ecosystem in the US, and of course there is in Europe. The geopolitical race is, I think, very much between the US and our allies and what's going on in China, to be honest. And this is, of course, of paramount strategic importance, not just on the computing side, but also on the quantum security side.
Well, coming up, where does quantum computing go from here then? We're going to discuss with some of Europe's top quantum contenders, the CEOs of New Quantum, Phasecraft and Riverlane. Join us for a roundtable in the studio. That is next. This is Bloomberg. Welcome back to Bloomberg Tech Europe. Now, in the long journey to realise quantum's full potential, one date stands out. December the 9th, 2024. It was on this day that Google unveiled its Willow quantum computing chip. That announcement spurred a rush from investors seeking to get exposure to the burgeoning technology, with publicly traded quantum firms soaring in the US. But more than a year on, are we getting closer to quantum going mainstream? Very pleased to say, joining me now around the desk are some of the top names in Europe working towards that very goal. Carmen, Palacios-Berraquero, founder and CEO of New Quantum, a British startup that builds networking infrastructure to link and scale quantum computers. Last year it raised $60 million in one of the largest quantum Series A rounds in the UK. Also here's Ashley Montanaro, co-founder and CEO of Phasecraft. It's a quantum algorithms company which has raised more than $50 million and works with the likes of Google and IBM. And Steve Brierley, founder and CEO of Riverlane, a startup that builds tools and technology to help reduce quantum computing errors. Really important within this space. The company raising $75 million in its Series C funding round in 2024. Thank you all for coming in, all really well positioned to talk about this from different angles. I want to start with a broad question about where this technology is right now. A lot of progress has been made, a lot of funds flowing into the sector in 2025. Over the last 2 decades, 25 years, there has been this gap between the hope and the promise and the reality, particularly when it comes to hardware. Where are we in this journey? When do we start to see the material benefits of quantum computing? And Carmen, maybe I'll start with you on that question.
Absolutely. Thank you, Tom. From my perspective, in 2025, the industry turned a corner where now we have better qubits than ever before. And we've demonstrated that these qubits are reaching the sort of performance that will allow them to be error correct them and really reach the performance that they need to. And the main challenge left is scaling them up. So we have good, robust quantum computers, but they're just small. We need to scale them up so that they're big enough to deliver commercial value. And I think we're seeing that in what's happening with the financial and commercial aspect, right? There's been, last year was 50% increase in investment into quantum. We started to see M&A. So I think we're entering this new phase where it's all about scaling up, consolidation, and racing towards commercial advantage.
Scaling, consolidation, and working towards that commercial value. Ashley, do you agree with that take? Was 2025 a pivotal year for quantum?
I think it is a really exciting time for quantum, and I think there's multiple reasons for that. One is that there have been really significant advances on the hardware side across multiple different technologies. And you mentioned Google's Willow chip, which is one great example of this. And I'd say also there have been breakthroughs on the algorithm side as well. I mean, there are algorithms that are achieving million-fold reductions in cost of certain problems compared with what was known previously. And I think it's because of the combination of these two things that we think that we're really on the cusp of this practical quantum advantage milestone that everyone's
And you sit
towards.
in the algorithm space, in the software space. I just want to actually, how dependent are you on that hardware progressing for you and the business to progress as well?
So in the end, having really good hardware is really important. But we believe that the hardware that we have now, or maybe a little bit beyond that, is already at the stage where we can achieve really exciting results. So the better the hardware gets, the better it is. But that's not something that we're just waiting for.
And Steve, error correction. This doesn't progress without error correction. Qubits are error prone. It's highly complex technology, but for the audience, you need the error rate to come down significantly, and that's where you guys sit. When do you agree with these assessments? When do you think we start to see real material impact, real world applications of this technology?
Yeah, so you're absolutely right that error correction is essential. The best quantum computers today, they can perform about 1,000 operations before errors overwhelm the device. But to get to large-scale commercial applications, we need trillions of error-free operations. And so that gap is bridged by a technology called quantum error correction. Mm-hmm. So it sits just on top of the physical qubits. And what's happening is we're correcting errors as the computer is running. It's essentially a real-time inference problem. We get some data from the quantum computer, and then we have to infer what's the most likely error and make a correction. And so this loop defines the clock cycle of the quantum computer.
So is this... I'm just trying to put a time frame to this as well. I know it's difficult, but are we talking kind of early 2030s when we start to get real-world commercial impact? I know it's in universities, it's in research settings right now. When do we get real kind of commercial impact from this technology? Carmen, I've asked you this before. Have you changed your time frame on this?
No, I remain with a similar opinion. I think towards the end of this decade is when that switch will happen, and that will depend on our ability to continue to make robust and high-quality quantum processors, coupled with our ability to network those processors together so that we can start to scale in a horizontal, modular way, which is how all large computing systems scale, right? All data centers, AI data centers, cloud data centers are based on us being able to network processors together to get to machines that are big enough and powerful enough to solve commercial problems. First of all, to be able to host quantum error correction, and then to host the kind of algorithms.
Am I right in thinking your new quantum is hardware agnostic? Is that right? I mean, there's superconducting, there's trapped ions. Do you have a clear view on which approach ultimately wins on the qubit and the hardware side?
At the moment, there's very credible approaches that are making fantastic progress. Trapped ions, neutral atoms, superconducting qubits.
Yeah.
They're all delivering on their roadmaps. They will all struggle to scale monolithically, but all of them can be networked in the way that we propose. And so we will be able to work with whichever leading quantum processor we need to.
Ashley, when you speak to investors, what number do you put on the potential value of this industry?
I mean, if you're looking across the whole industry, it is incredibly difficult actually to put a number on this, because there are individual applications of quantum computing where that one application is well into the billions, right? So, I mean, what is the value of developing the next lithium-ion battery? What's the value of developing high-temperature superconductors that enable low-loss power transmission, or a host of other applications? And, I think it's basically the dawn of an entirely new technology, the telescope of the 21st century, as we often say. And so, the opportunities are really gigantic.
Which industries, Steve, are best positioned to benefit the most? Where do we expect to see the most impact on an industry level from this technology?
I think the earliest industries will be those that are trying to develop new medicines or new materials, as Ashley alluded to. I mean, what quantum computers can do is solve chemistry, solve material sciences in a radically new way. So we've been trying to do this for 100 years now. Traditional computers struggle to scale with these systems. And so what quantum computers enable is for people to design on computers new medicines or new materials in a way that currently happens in laboratories.
You are all examples of European talent in the quantum space. You're all creating intellectual property. You all have incredibly talented team. You're all doing amazing research that will have value. Does that all ultimately end up being commercialized by the US? Ashley, do you have a take on this?
I don't think it's not inevitable. I mean, so we are a company that was born in the UK. We now have a US office on the East Coast. The US is also a fantastic place to be. There are amazing opportunities, but I don't think it is axiomatic that companies that are founded in the UK end up needing to eventually end up in the US. And essentially what I think Europe needs to do in order to compete and to enable companies like ours and the others around the table to stay within Europe is enable things like the financing that's needed at later stage investments, to make sure that the talent pipeline's there, so that the amazing sort of academic excellence that we rely on is continuing to come through, and also just making sure that governments support the market and provide that signal that, this is a really exciting technology that's pivotal for these different
Carmen,
nations.
do governments need to be more proactive in this space? And if so, what could they do to support your sector?
Governments need to be proactive, and government funding continues to be very important, maybe critical for quantum computing for the next few years. The UK just announced over Christmas £1 billion that are committed to quantum computing during the spending review timescale. We're waiting to see how that's going to be deployed, and that's going to be really critical that it's deployed as soon as possible. But I think that the UK, so a lot of the quantum science has come from Cambridge, for example, where Steve and I are based, and it's been really smart in how it's been commercialized, because essentially what the UK has done is that it's creating leaders, global leaders, in essential pieces of the quantum computing puzzle, right?
Yeah.
So if you ask an expert, who are the leading companies in quantum error correction or in quantum algorithms, they will mention Riverlane and Phasecraft. I mean, if you ask who are the global leaders in network quantum computer, they will mention New Quantum.
Do you worry about being M&A targets? There was a lot of M&A activity in the space last year. Are you having US investors tapping on the shoulder, US companies tapping on the shoulders? Could you become M&A targets? Is that a concern?
I think this is a good problem to have. So I think that there has been a lot of M&A activity in the sector recently, which I think is a sign of firstly the huge amount of excitement, but also in fact this is a huge challenge. In some cases, people are feeling, for example, doing software is very hard. We can't do it on our own. We want to get someone in, but I think, for us, it's far more exciting to do this sort of thing independently.
We have a question from a viewer asking about what quantum and encryption cracking could do. If you get quantum computing, it can crack encryption coding, and what it could do to the crypto space. If you have a view on that, Steve, there's potentially certainly an encryption shock that comes about as a result of the application of quantum computing.
Yes, that's right. At a trillion error-free operations, quantum computers will be able to solve number theory, math-type problems that could break current public key encryption. And so it's really essential that standards bodies and the industry transition to what's called quantum-safe encryption. That's a process that's been running for over a decade now. NIST has produced new standards for schemes that would be secure against future quantum computers as they are built. So that's absolutely a critical challenge right now, because we can see that coming on the time frame of kind of early 2030s.
Carmen, just very briefly, should we brace for an encryption shock?
Well, absolutely, but how much depends on the longevity, or how long you need to keep your data safe.
Yeah.
So if you care about a time scale of 10 years, then you're already probably late. If you care about a time scale of seconds or minutes, you have a little bit more time. So it really depends on the industry.
Okay, fantastic. Really fascinating conversation. We could keep this going for a long time, but we've run short of time. That is our panel. Carmen Palacios-Berraquero, CEO of New Quantum, Ashley Montanaro, CEO of Phasecraft, and Steve Brierley, Chief Executive of Riverlane. On the next episode of Bloomberg Tech Europe, we're going to focus on Sweden and why the country has been called the Silicon Valhalla. Catch that episode March the 13th here on Bloomberg TV. That is it for Bloomberg Tech Europe. The Pulse is up next. This is Bloomberg.